right. And we're missing. All right, we have a full house. Okay, so we're going to take it slow at the beginning because I know it's going to take a while for folks to join us again. Again, thank you very much for joining us for the second part of our webinar on whether AV1 is ready for RTC prime time. And I'm Pierre-Antoine Mieux. I'm the executive director of Alliance for Open Media, and we have 4 panelists with us today. We'll start by having folks introduce themselves, and this would be also an excellent time for the audience to start jotting down your questions in a Q&A here on the right side of your screen. Again, as we did for the first session, we'll drive the Q&A using your questions. And again, this is your webinar, so don't hesitate, don't be shy to ask questions. And without further ado, I think we'll just start with Sashi. And actually, let's see. I have some slides here that I can share. Actually, I think we're going to start with Michael because that's the first one. All right, this is a time where I actually try to share something. All right. So, Michael, do you want to tell us a little bit more about yourself? And
Sure, I'd be look at that. That screen share goes, and you'll flip the slides when I ask?
Yeah, absolutely. I'm just about to do it.
I am Michael Horowitz. Please flip. There you go. So, my RTC background includes early productization of video coding standards, including H.264, H.264 SVC, H.265, and AV1 with the Google Duo product back in 2020. And today it's used in, AV1 is used in Google Meet. Next slide. Please.
Yes.
There you go.
Yeah, there we go.
So I can't read my my slides. Oh, look, I can move that. Great. So here are some key points that I hope come up during the panel discussion, but in case they don't, I'd like to just emphasize them now. LibAOM, an open source AV1 encoder, has several RTC optimized modes. Eric, I believe, mentioned them in his talk. And we use them here at Google in our video calling products, video conferencing and video calling products. I also want to mention that the video codec capable of delivering high compression efficiency with lower complexity is often the best choice. And so, as many of you know, there's often a trade-off between coding efficiency and complexity, even within the same encoder, because encoder can make choices. AV1 really shines in the breadth that it can achieve. And finally, and closest to my heart, don't underestimate the importance of low bit rate video calling. Here is some data from a couple of years ago. The percentage of calls with less than 100 kilobits per second available bandwidth in the US, 10%, India 25%, Indonesia 30%. It's worse in some places. The point here is that AV1 allows our users to make high quality video calls where no call was possible before. And so that's a really important point, at least to me. That's it for me. Thanks.
Thank you, Michael. Tahani, do you want to tell us a little bit about yourself and what brought you into RTC and AV1?
Sure, definitely, yeah. So actually, I have a more probably diversified background, more than just AV1 and RTC in particular. I've been working on different codecs, namely SVT-HEVC, SVT-AV1. SVT-HEVC is made by eBrisk to make Michael happy. And I've also, I was the technical lead for SVT JPEG XS, worked on Funky with folks from Meta on optimization. And currently I'm focused more on GenAI pipelines. That applies to all different scenarios, including video. And we can probably talk a little bit more about that later on. Yeah, the key points that I wanted to highlight today is what is Intel contribution towards AV1 and RTC in particular. We do see that AV1 is adopted. It became popular, but we just need to understand that this is not happening today. Like AV1 decode support, for example, in Intel Core processor happened 4 years ago. Encode came later, but it still happened in our discrete GPUs in 2022, which is 2 years from today. And the encoder has been around for at least almost a year now in our Meteor Lake and Lunar Lake. Aside from that, Intel has developed the SVT-AV1 software codec, which made great progress as well, especially over the last couple of years, where there is a great improvement in terms of speed and bit rate reduction. But also, the SVT team has actually done a clever, I think, decision to work on fast decode option, where you are not only optimizing for the encoder, but also for the decoder. And in that way, you are reducing the congestion on the iGPU, for example, where you can free up some resources for the encoding as compared to, like just use all of it for the decode. And then I just want to mention that SVT-AV1 also supports RTC use case, and there is a mode in SVT-AV1 that does that, and the latency there is sub-picture latency, so it's probably on average around 10 milliseconds or so. So it is, it's quite good. Yeah, and that's all for me.
Thank you. Thank you, Tani. I'm sure we'll get back to you later. What about you, Sashi?
Hey folks, thanks Pierre. My name is Shashikant. I'm a group engineering manager at Microsoft. I've been working in real-time video for more than 10 years, and currently my team leads the development of the end-to-end media for real-time products in Microsoft. Some of the more popular ones are Teams, Skype, and Azure Communication Services. We also have a data science team that constantly analyzes and does data analytics around media end-to-end, and this intersects with quality, reliability, performance, and how codec plays into this strategy. Over the last few years, one of my missions has been to figure out how we can get more and more AV1 into our scenarios end-to-end. And I think for those of you who've been in the first part of the panel, you've already heard a lot of the benefits that come along with this codec, and I'm sure we'll dive deeper into some of the topics in this session as well. One of the things that has been a huge learning experience for me in the past decade and plays into this discussion is, when you try to deliver a product across platforms that works well across network conditions, across various device capability levels, you really start to realize the challenges of what it takes to succeed in it and exit that kind of a campaign. And I have a feeling, that's going to be core to a lot of discussion around AV1 in prime time. So I'm excited, looking forward to the discussion, and thanks for having me here.
Yes, thanks, Sashi. All right, and next we have Patrick.
Cool, thanks. Patrick Farrager. I lead the global product and marketing teams at Agora. Been in video and audio for about the past 20 years, business video conferencing and audio at Polycom, a stint at Dolby, and about the last 4 years at Agora. And at Agora, we're building out basically a platform as a service to enable developers to build real-time experiences and applications and deliver those globally across devices. So echoing what was said before by a number of the panelists here. And it's critical to deliver the best user experiences across the various devices and network conditions. And we're really excited about AV1 and the fact that we've spent the last few years optimizing our version. And I think we're ready to see this happen in prime time. So excited to be part of the discussion today.
All right, Patrick. And actually, so building on this, ready for prime time, what does that mean in your mind for Agora, really?
Sure. Ready for prime time really means that when you look across the breadth of verticals and use cases, which then implies that developers are building applications that end users need to be able to access across wide ranges of mobile devices, from high-end to low-end, wide ranges of PCs, high-end to low-end, native apps, browser compatibility. All this has to be taken into account and work well to make sure that we're ready for prime time.
So I'll go backwards. Sashi, what about you? What does prime time, ready for prime time mean?
Yeah, I think there are a few different aspects. So on the feature side, we don't want to go a step back from what all we have developed as a part of, say, the evolution of AVC or SVC. And, infrastructure has been built that is delivering substantial value to a lot of users daily. So we can't take a step back there, and this sets the bar pretty high. So we definitely need certain features that don't drop the network resiliency bar, that don't drop our ability to respond to changing or fluctuating conditions. Whether it is control over the quality of the frames, whether it is the reference structure control, these are all various different features that we would need deep control. Then there's the aspect of devices and capability. I think others have already spoken to quite a bit of detail here, so I will not, repeat it. But I also want to add a third aspect, which is, if you take a product like Teams, we're not only a first-party ecosystem. We end up doing a lot of interop, and interop tends to hold us back from completely migrating forward a lot. So the part that is so difficult to control and also so core to defining whether something's ready for prime time is the ability to, interop with people who also are using AV1. So I think that's an area where we're still trying to understand what does it take. But in terms of a codec, in terms of devices, we would love to see more hardware out there supporting this. We would love to, continue working on the codec so software versions can do more. But the interop part is something we still haven't fully figured out. Yeah.
What about you, Tahani? What does prime time mean?
Yeah, I think I second what Sassy and Patrick has said. Definitely, device reach is something that it's there, but it needs more work, right? We need to make sure that AV1 is enabled, especially hardware-wise. Mobile, for example, it needs to be enabled and not the high-end mobiles, because that's not the target. It is probably here, but not in other regions of the world and other areas. So the infrastructure is there, just needs more work. Lighter software also is also an option. So I think we'll have to work towards that, actually.
What about you, Michael?
To me, prime time means, is a codec ready for prime time? Can it be used in a product to be delivered at scale? And I mean, for me, the answer is definitely yes for AV1. And in Google Meet, for instance, we've rolled out 100% to iOS. AV1 goes out to iOS, to 100% to Android, all phones. This is software. We use libaom. And I hope I'm able to say that. Well, I certainly am able to say it. Whether
Too late, Michael. It's too late.
Later, please scratch this from the. No, I'm sure it's fine. It just, as I mentioned earlier, allows our users to make calls where they just couldn't make calls before, and it just works. 25% of all call minutes in Meet right now are coded AV1.
Okay. Actually, so I want to go back. So first, I want to remind the audience, please ask your questions in a Q&A on the top right of the UI. We'd love to get your thoughts and really focus on what you'd like us to focus on. But in the meantime, I just want to go back to this interop issue and tie that in with if you had one priority for the community as a whole, to support the deployment of AV1 in RTC, what would that be? Is there anything that a community can do, Sashi, for instance, to help overcome these interop issues? Have you run into specific issues, problems?
I don't have the perfect answer to that, but I can give some examples from my experience. So a lot of times, various different people have the same intent, which is to adopt AV1, but they're blocked by different things that they feel are important. Some of the cases where I personally engaged with partners who are trying to migrate are around features which help them regulate the quality of encoding. And it's not just these features in software. For it to be realistic, that level of control needs to be on the hardware. And we've been working with hardware manufacturers and partners closely to get this support in. But if you look at the history of something like hardware feature set over the years of hardware development of a codec, it's something that iterates. So I think figuring out what top feature gaps across hardware and software can actually get the maximum uplift to me sounds like a good bet, because end of the day, if that's unblocked, people do want to improve call quality, reduce their bitrate footprint, and even not maintain two codecs. I don't think we need to motivate them on those aspects.
Do you have any specific example of a gap between hardware and software, and maybe on the encoder side, I imagine, like something that comes right to mind?
Absolutely, yeah. So per frame QP control, controlling specific reference structures, whether it is about which reference to use or whether to code something as a longer term reference, temporal scalability, and controlling bit rates of each layers. These are all aspects of quality control algorithms that various real-time products have invested in, and to sort of take that investment back and rely on a V1 hardware version of the algorithm is scary. And we do spend a lot of time benchmarking it, but it's not uncommon for that not to meet ship and bar.
Anybody else on that topic of?
I'd like to chime in. First of all, I guess I don't need to be here because he answered it exactly as I would have said. Those are
All right,
exactly.
let me see if I can turn you off here
I'm out.
somewhere.
Yeah, thanks. I want to mention something that I've been doing this a long time. And when I say this, I mean RTC. I was at Polycom, Patrick. I don't know if we overlapped, but over 20 years ago. So you don't look old enough to.
I shaved my head for that.
Before the pandemic, video conferencing, video calling was, I don't know how to put it, not first and foremost, at least when I would talk to hardware codec manufacturers, that was not at the top. Basically, I would see encoders that were targeted, designed for streaming application, broadcast applications. After the pandemic, I mean, the pandemic was terrible. Everyone knows that, but there are some shining little things that come out of it, and RTC that really has just changed the perspective. I've talked to several hardware vendors, including Intel, and it's so heartening to see that these things like frame level QP control and reference picture structure control, they understand it now. It's fantastic. I'm hoping that understanding turns into something that's real and that we see. Actually, I know it is because I've seen prototypes, and actually that some of those things may actually be in the real world now. So I'm very encouraged. Thank you.
Tahani or Patrick, anything to add on this?
Not for me.
All right.
Just
yeah,
quickly, like another focus maybe is power consumption, right? In these use cases that people tend sometimes to forget, but it's very important in the RTC use case, especially on mobile devices, even on like PCs, but on mobile it becomes more important where you cannot just drain the power, right? So lighter codecs are important.
I'll echo that definitely. We have a very large user base in countries like India and where entry-level Android devices are prevalent, and this is a very key concern for mass deployment.
But I think also what was just pointed out is it's not only deploying AV1 in hardware, but it's deploying AV1 enabled for RTC in hardware. And so it's really getting those two dimensions together. I think that's tricky because as you pointed out, very different requirements between pre-recorded movie and doing what we're doing right now, which is live, real-time communication. And actually on that point, what does ultra low latency means to you? because, I was just in a conference where ultra low latency was 7 seconds, but that's obviously not the case here in RTC. So and I've heard, Tahani, you mentioned, 9 milliseconds, right? So, subframe, what's the
Okay.
sweet spot? What's the sweet
Yeah.
spot for low latency?
Well, so there's this study that's older than I am, I think, G.114 out of the ITU that talks about, some people are familiar with it. It's really not about video, it's about audio. And if I recall correctly, transparent end-to-end delay. This is not just the codec. This is the whole network, the delay coming out of the speakers in that case, of 150 milliseconds or less is transparent to people. We won't notice it. If it's more than that, we notice it. For me, after it gets to be about 250 milliseconds, I start talking over people. It gets a little bit cumbersome. I've heard people say as high as 300 milliseconds is acceptable. To me, 200, 150 to 225 is really my sweet spot.
Yep, that's spot on for RTC. And after that 275 or so, many users start to get dissatisfied and it rolls off pretty fast from there. And it's also interesting that as we're now, that's for human to human communication, but the same does apply when we're looking at human to AI and conversational AI use cases that are going to be more lifelike. The same rules apply, and we have to consider that as well.
All right, maybe moving on to a question from the audience. Is there an effort around a low-complexity AV1 software encoder to support the legacy of thousands of devices over the past decade?
Yes. LibAOM, if you look at speeds 10 and 11, that's what we've rolled out to legacy devices. All Android devices that have meat can use AV1, and it works. I mean, we looked. I watched the talks from earlier. You have to look at regression in battery use, regression in power use. You got to look at regression in thermal throttling, and we would not have rolled it out if we found regressions in that. And these devices are well, some of them are very capable, and some of them are quite old entry-level devices. I like to target when I'm tuning things up for an entry-level device that's greater than 5 years old. Mobile device when I'm looking at mobile devices.
Yeah, it's fairly similar.
Go ahead, Patrick.
It's fairly similar for us. We started development working with LibAOM about 3 years ago ourselves, and it had to optimize and rewrite a number of the modules to suit our needs. But similar case, we're able to have it run across a wide range of devices, including down to many of the entry-level Android devices. We do need to, of course, consider the overall parameters that Michael indicated, and we try to track those in real time and then determine how to make sure we deliver the optimal experience.
Yeah, adding to that, I think my outlook on this is, since even AVC, we've had like scalable complexity in codecs, and we typically tend to sort of spread this across device capability so that we can maximize our reach. The same kind of model still kind of exists here, but if you look at the chronological way we develop codecs, you find a starting point and then you try to cover more. So I think AV1 is doing well on that journey. I'm glad that various folks in the industry are focusing on trying to now hit those low performance devices. I know the questions about software, but I just want to add even an angle here. Even in hardware APIs, there's a low complexity mode for encoding, for example, which we actually find very useful because even when hardware is offloaded, power consumption may not be trivial. And if you take a product like Teams, Zoom, or these meeting products that are used 8 hours a day at a stretch, and it's just not sustainable to use the high power consumption outcome on a lot of these business laptops, which are pretty expensive, claim to be powerful, but at the same time may not have a fan, right? And you could be in a tropical country taking a vacation, joining 8 hours of meetings. So I think those are important as well. but definitely, yeah, there are efforts around this.
Hani, any thoughts?
I would say, of course, yes. SVT AV1 is working towards that. And
Yeah, so what can you say? So how much gains have you seen with SVT AV1 over the years, compared to the reference model or LabOM or
in terms of bitrate reduction or
yeah, and complexity?
and complexity. Okay, I think I have some numbers in bitrate reduction. So there is probably around 12% bitrate reduction, depends on the mode we are using. SVT AV1 supports M8 to M13 for low delay use case, so it depends on the mode. The gain will be different. And then again, the average latency is around like 10 milliseconds. So that's, I think, quite promising.
And actually, in the chat, somebody suggested, so we've been talking about RTC as in what we're doing right now, so live communication. What about gaming, where their latency is a couple of milliseconds, right? So have we seen a lot of AV1 used for gaming, cloud gaming or just multiplayer?
So I can offer a perspective here. The cloud gaming needs server compute to be able to deliver at scale at a cost point that is feasible, and gaming fidelities are high. This combination continues to be a challenging business proposition, but it is not. It is something that I'm sure various players are exploring. So the operating point of the requirements versus the complexity of live cloud gaming tends to be slightly different to my average daily meeting. So that changes a few of the things.
Thanks. Let's see. Let me go through here. Well, here's maybe a tricky one. So let me just go to this next question from the audience here. Here we go. Which one would you pick today for real-time software encoding, LabOM or SVT AV1?
It depends who you ask.
Well, maybe starting with you. What are, pros and cons?
Again, like there was a comparison and I gave some numbers, but at the end of the day, I'm not the end user who is deploying this because we are Intel providing solution. I'll of course say SVT AV1, but maybe Sassy or someone who has probably tried both, not Michael, can give more perspective.
I don't have numbers handy. We do look into these options for the software codec, but all I want to say is it's a very fast changing landscape, and it's been amazing to see all the improvements in various tracks here. So I can't pick one of these, but what I would say is take your use case and compare it with what's available with the current codec, because each of these efforts is focusing on solving a particular problem. Maybe not the same problem right now, but a year down the line, they would have solved two of the same problems. So whatever aligns better with what you're trying to solve in your product, try to evaluate that for the fit, because all up, I think these are two excellent implementations of AV1, right? Like, I don't think there's like an obvious, close my eyes, I would pick this. Yeah.
So, like with all things video encoding, it depends, right? Essentially, it depends on your specific workload.
Yeah.
All right. But actually, so on this open source, so how do you see the importance of open source implementation in the AV1 ecosystem, especially for RTC? Has it been a critical part? Anything we can do to improve open source implementations? Any thoughts on this?
Open source is naturally challenging when various different big players are all trying to, evolve the same code base. I think to me, that continues to be a big challenge, but I'm a huge proponent of developing together. So I would still vote for it, but it's not easy. I mean, take a look at a team of 10 people trying to develop a product, a team of 100 people, and then a few companies of 100,000 people each, right? Like it just like goes off the chart. So to
So
me,
what
that's
you're
still uh
so what you're saying is, in fact, here, so too many people are involved.
It's a function of like, the more coordination you have to do, the slower you move.
Yeah,
So
sure.
that's just reality, but it's still a direction in which long term you add more permanent value. So we need to navigate that carefully together, looking at common requirements of the industry and maybe finding ways to contribute that can help everybody.
Any other thoughts on open source and AV1? How's the experience been? So Patrick, you mentioned you Agora ended up using some open source library to start with. Has that been a positive experience?
We spent the last few years rewriting most to basically optimize it for our needs, and in essence creating Agora AV1. So I think for us it was great to leverage as a starting point, but
Mhm.
to make it work for
Okay.
our needs, we had to do significant work. I will echo that we need to make sure that to get to the next phase of primetime adoption, we do have to focus on making sure things are interoperable and working with the ecosystem to scale up, right? And so I think we can move faster by making sure that we do that for key ecosystem partners.
Let me go see here in the Q&A. Actually, we have here a pretty specific question, but let's go to it here. Okay, that's directed to you, Sashi, I think.
Mm-hmm. Yes.
So,
So the question seems to be whether we want to look into adopting AV1 for remote desktop technologies. So remote desktop technologies, there's a variety in them. If you look at some of the virtualization tech, it actually is not just purely streaming. It tries to virtualize various aspects of the app, and that's one direction of the industry. But limiting the answer to just a streaming version of remoting, we do want to get the latest and greatest. But every single challenge that we spoke about till now becomes a big issue here. If you're remoting into a cloud or a remote PC, but let's say your device itself is something older, you may not have the hardware offload. Even if your device is newer and if you're using offload, supporting HDR may not be there yet, or it could take more work. And are you going to be okay seeing your monitor at 8 bits instead of something richer, more contrast? So these are all questions where mine ends up being an opinion. So those are challenges and we should solve those. But as and when they align with a critical mass of, the usage there, we obviously want to move to a newer, more modern, efficient codec. There's no doubt about that.
you see is RDP mostly desktop to desktop, or do you see a lot of use mobile to desktop and desktop to mobile?
You're catching me where I don't have the telemetry handy.
Okay.
RDP, vast majority of the usage is desktop to desktop or desktop to cloud.
Yeah.
I don't know the percentage of mobile, but I know it's not major. Yeah.
I want to move maybe slightly back to deploying AV1 at scale, and maybe you mentioned some pretty impressive numbers in terms of usage of AV1 on Google Meet. What's been the single biggest headache or obstacle to getting at scale? I mean, anything that just comes to mind immediately.
Well, immediately, the complexity, the computational complexity. So when I started at Google several years ago, AV1 had just been ratified, or actually it was ratified about the same time I joined. And I came to AV1, as I mentioned in my intro, I like to be first or one of the first from codec ratification into product. So I came to Google to get AV1 into product. Now, The guy that was, I don't know, my skip manager, was not thrilled about the idea because he didn't believe it was possible to work on a 5-year-old, 10-year-old entry-level phone. And I have to say I thought that was probably correct, but I don't like to take what I guess. I like to go out and get the data. And so I was allowed to spend a few months learning how to tweak and tune AV1. I was using libaom, and I gathered enough evidence that I convinced myself that it was possible. I obviously convinced a bunch of people internally that it was possible, and so the productization began, and first release was in 2020 with the Google Duo. But that complexity was the key, and AV1 just has this. It has so many tools. It has so many nice features that allows you to trade off computational complexity for coding gain, because you can have just tremendous coding gains if you're willing to spend the CPU cycles. And I'm talking about software here. But at some level, I guess the same thing applies to hardware. But if you want to tune it down, you get less gain, but you use less CPU. Where do you want to live on that curve? That's really the question that every implementer needs to answer. And we found a spot that works, actually several spots that work quite nicely for products. So that was first and foremost. Now, another thing that we haven't mentioned, how do you transport that bit stream? It's, we're talking about AV1. It's a bit stream. You don't just throw a raw bit stream over the network. We use RTP for AV1, which hasn't yet been published, even though it's been sitting in the queue for 5 years. That's a dig at Pierre, by the way, for everyone who doesn't know, even though it predates his time. But we're using it. Microsoft's using it. Lots of people are using it. That has to be mature and useful, and it is for RTC. But that was another thing that needed to fall into place in order to happen. Those are two things. I could go on, but I'm getting tired of hearing myself talk, so I pass it back to you.
Anybody else on their main challenge, and maybe Patrick?
Well, I think one is that, for the majority of our use cases that our developers target, the quality of experience is fundamental, and everybody agrees with that. But I think one challenge we find is that what does that really mean in terms of how the customer will evaluate and measure their metrics? And for us, that differs a little bit by industry. For example, in a social app, if you can deliver a much richer and better experience with the same available bandwidth, and that increases the engagement and time spent in app, and they're measuring that, and you conduct a controlled experiment with them, they'll say, okay, this is a no-brainer. Let's roll out AV1. And the same, for example, in telehealth, some of our customers are measuring. They're saying we want our patients and doctors to rate this, and rate that the telehealth experience is going to be a better experience than being there in person. And so these things have to be taken into account, and we have to answer those questions for our customers to really get them to adopt. And we're aggressively working on that with our customer base.
Anybody else wants to chime in on their biggest challenge deploying AV1 at scale? All right, so I'm going to use this opportunity again. We're getting close to the end. So for the audience, if you have a burning question, now is the right time to enter in a Q&A. I want to go back to something that Tahani mentioned in our opening statement is, favorite topic, machine learning. So can machine learning help RTC? I mean, can it help find that sweet spot in encoding tools, right? And when you have this incredibly multi-dimensional parameter space, is that where it can help? Anything that ML can do for RTC and AV1?
I'll give it a shot. I think I'm going to talk about both ML and Gen AI, because Gen AI is like everyone is talking about it, so we should probably bring it up. So ML, I think it can help in the sense, maybe have a better estimation on the bandwidth and how we can make use of that. It can make use of the previous data to kind of allocate resources accordingly. So in that sense, I think it can help RTC. But there is another angle, AI angle to it, which is Gen AI. And I think it is probably, for me, more promising and more short term, which is example of like transcription, language translation, real-time language translation, summary of the meeting, maybe in content share, you can probably do some caption. Things like that, I think, are very possible, and I think are probably shorter term goals for AI rather than. But of course, like other people can probably have a different perspective. But I think rather than just like improving the quality of RTC, it's more adding some features and capabilities to it.
I'd agree. I think it's up and down the stack, and for a while with our Agora coding technology, we focused on applying ML to determine exactly what to do based on the different devices and network conditions and situations. And I think most industry players are doing the same. But agree, I think at the next level and looking further up the stack, we see just different numbers of use cases. Obviously, the more engaging agent type, real-time engagement with AI agents, there could be more of AI companions, and that can range from something very casual to an avatar with lip sync, all the way up through something that's more like a digital twin and much more engaging. But we're also seeing use cases that it's just for fun. And do I want to convert my live stream into a cartoon and do that in real time? And I think that these are some of the cool emerging use cases that we're seeing.
Yeah, so I'll offer slightly. Go ahead, please.
Go ahead, Ceci.
Go ahead.
Now you can finish.
Okay, it's okay. I'll just be quick. I thought I guess that, for example, things like background generation is probably already used in tools like Google Meet and Teams. So that's something that's probably already in. So if we already have AI in these use cases, then would it be too much of an overload to add other things? And plus, you can offload these type of pipelines or workloads into the NPU, so you don't add to the iGPU. So that's something I think useful now. Go ahead, Ceci. Sorry about that.
Yeah, no worries. In terms of, just going back to the original question that Pierre asked, right, around learning algorithms around quality. I personally believe there's huge potential there. Today, anywhere you can collect data with some sort of a label or a ground truth, we can build a model and we can quickly evaluate whether it can actually do something that our traditional or rule-based algorithms cannot. There are some internals in the codec where some of these potentially could belong, but there's no well-defined way of plugging in, let's say, a ML model into substituting an internal part of the codec. But also, like, there are two tracks here. One is go and optimize the performance or the efficiency of a particular part of the coding process and use maybe ML-driven boosting. But there's also this whole track of like a neural codec, which is an entirely different thing. And that all up reimagines this. It represents the frame differently. And it's really, it starts making me think, oh, I don't know video coding anymore, right? It has some potential advantages, like they maybe all will hit a common neural processing unit, and we won't need to keep building, fixed function hardware offload every generation. And it could all become a software negotiation aspect. There's a certain simplicity to that seems like a dream, but obviously, it's still becoming less and less dystopian every day. We're not there yet. So if we can find a way to plug in the ability of an average person using AV1 or an average developer using AV1 to infuse intelligent models into certain key aspects of the coding process, there could be some potential there. Yeah.
What about you, Michael? Any deep thoughts about ML?
No deep thoughts, but one thing that I didn't hear spoken about, there's this holy grail of evaluating video quality. PSNR is one of the tools, SSIM. Many tools are used. Many tools have been used in the past. I'm a big fan of lining people up and burning out their eyeballs looking at video and really double blind tests. And Tahani's shaking her head because she had years of that. That's what we did at eBrisk. But maybe AI could help us out there. Maybe there is maybe that holy grail can be achieved with AI. I wonder about it. I'm sure there are people working on it. I'm not aware, not following that research, but boy, that would be great. So that's my thought.
Okay. Yeah, I think, certainly the challenge I've seen is that in some contexts, the fact that my shirt would look red instead of blue does not matter. Of course, in other contexts, and telehealth is one of them, or surveillance, it absolutely does matter. And of course, and motion pictures in between the two probably. So that's a big challenge, I think, with AI, generative AI in general. Let's see. We're about to be out of time, so maybe should probably go around one last time, and see what any last thoughts, Patrick. Maybe starting with you, Patrick. Any concluding thoughts on prime time, RTC, AV1, the future?
I just start with definitely excited to see what comes next. And I know we've talked about driving adoption across devices and what's needed from the ecosystem. But I also see that there's a lot going on in spatial computing and VR, and the fact that AV1 can also scale up into some much more advanced use cases, and excited to see what comes there and at the intersection of AI. Overall, thank you. It's been great to be part of the panel and part of this discussion.
Thank you, Patrick. Yeah, and I'd love to be able to take this in a truly virtual environment, right? It's just I don't think we found a way to make that happen just yet. But I'm a big fan of the idea, though. What about you, Tahani? Any last parting thoughts?
No, I just wanted to bring up one point, because we talked about pandemic and how that boomed the RTC, and we can see everyone is stick to their devices now, and there is definitely lots of room for improving these use cases. For other use cases, we can see online education, telehealth, you do consultation through video. I probably don't like it, but it is true. That's what we do right now. There is the live commerce. People are just buying and selling things using these tools. So definitely the pandemic just caused it to become more important, but it won't fade away. It's actually will become, I think, more important as these use cases grow, and we are seeing them grow. And then just to add to Michael's point, so VMAF is based on an ML model, just to add to that. So there is work being done then, and there is Funky from Meta also that is a VMAF sister, but it's better in terms of speed, that is being, I think, still work in progress, but it's coming up. So there is work done there for visual quality assessment. Just one last thought. I heard this from, I think, John, the CEO of Max, during the GMAX conference. He said, how are we measuring visual quality? It's always hard to measure it because it's subjective, right? And I thought it's funny. He said, for us, video expert, VMAF is probably 90 plus. For our friends, it's probably 80 plus. And for my parents are probably 60 plus. I think my parents are probably 50 plus. So I think it's all subjective. So it really comes down to the final user. And that's the trade-off that Michael has pointed out. How is the quality versus the speed and efficiency? Yeah. And thank you again. I'm very happy that I participated today.
No, and thank you so much for joining us. And again, I think you brought up this point where the pandemic was really an inflection point, because it made RTC go from an exception to the rule, right? And
Yeah.
I mean, taught people that what we're doing right now is normal or certainly part of everyday life. So that was a big
We're working
inflection.
remote, right? So it's not like you go to the office every day. So you
Yeah,
have
no,
these,
yeah.
yeah.
And I look at, how do we bring people together? And we would have had to all fly to a meeting somewhere in the world and maybe have only 5 people sitting in the audience. So now so I think that's been a really net positive change, actually. What about you, Sashi? Any last minute thoughts?
Yeah, so completely agree with the conditional perception of quality and how we need to still figure out what plays into that. There's huge potential. So the video codec impact, given the scale of RTC in recent years, has just become insane. And we spoke about how it can reduce bitrate, improve quality, and lower bitrate. But there are these secondary impact, tertiary impact. When we started playing around with AV1, we started seeing call setup time improve in low bandwidths because we reduce congestion. And this is not something you really plan or expect, but that could be the extent of impact here. I've been in cases where I had only a 300 kbps network and it affected my functioning. And to be able to function, for a change in such a situation is huge. So I think there's huge potential here, and it is great that we are talking about it. It's great that we're aligning on these things. I would love to, figure out a direction in which the industry can move together and invest in features and improvements that can benefit everybody so the adoption continues to gain momentum. I would really like to find an exit from the AV1 campaign where it's AV1 100% instead of having to live with multiple codecs. But great discussion today. Loved hearing everyone's perspective. Loved the questions. Thank you for having me.
Yeah, thanks, Sashi. And actually, talking about low bit rate, don't tell United, but I think I was on a Zoom call while we were taking off yesterday from Boston through a VPN because apparently United will not let you do Zoom on their satellite, but I guess you can't tell through a VPN. But anyway, so it does work at very low bit rate. What about you, Michael?
Well, first of all, thank you very much for inviting me to participate, and thanks to all the panelists here. It's really been great hearing your perspectives, and so interesting that they align so closely with what mine. I really have been doing this, as I've said, a long time, and AV1 is the first time that I have this desire to help people have video calls when they couldn't do that otherwise. I started by pitching grandma in some rural whatever, speaking to grandson and whatever, and that got traction here 5 years ago when I started working on the project. Today I have to be a little more careful and say, well, it's the CEO in the back of his or her limousine and going through a tunnel. It's the same thing. Just make it work. When I started, ISDN was everywhere. You'd start a call, it would connect like that. Never an error, never latency, never anything. It was great, super expensive, super exclusive, no scale at all. And then IP came in, and all of a sudden, all this bandwidth was available, but it's still in many cases not ideal, not pristine. How do we make this technology work for everyone everywhere? And I think AV1 is a piece of that, is part of the answer.
Yeah, certainly from my perspective, that's changed the way I communicate with my family, including my parents, right? It's something they couldn't even conceive of just 20 years ago, being able to have that direct connection. And on a different topic, Michael, I'm told that AV1 over RTP spec is just at the 99% bar. So I don't want to get your hopes up completely.
No,
but
I know how to
any
do
day
it.
now. Any day.
I'm glad you're aware of that. Yes, we're hopefully in the final stretch, and from your
It's
lips
there
to the CWG's ears.
Yeah. Yeah. Anyway, so again, thank you very much for joining us today and for this really lovely and interactive discussion. We have the list of all our LinkedIn's on the chat. So again, so if don't, for all of our audience, don't hesitate to reach out to speakers and panelists directly. Please feel free to bug me if you have any questions about AV1. And again, thank you very much, everybody, for your time, whether it's morning, noon, or end of the day. And we hope we'll see you all very soon. And again, thank you very much, all.
Thank you so much. Bye.
Thank you.
Yeah.